Alright, in this video, we introduce ordinary differential equations, ODE, or simply differential equations, which is an equation involving the derivatives of a univariate functions. For example, let's say y is a function of x, it's a univariate function. Then, for example, y plus 3x y prime minus y prime squared equal to 0. This is an equation that involves the function y and its derivative, first derivative, and here also. So, and this term is also nonlinear because it's the y prime is squared. So it's called nonlinear first order ordinary differential equation. Another example, let's say y plus 3x y prime minus y double prime equal to 0. In this case, we have here second derivative of y, but this is a linear term. So this is a linear second order ordinary differential equation. More generally, suppose we have a multivariate function involving x and z0, z1, and so on up to zn. So this is a function of n plus 2 variables. Okay, so if we substitute in these variables the derivatives of y, then we have f of x, y, y first derivative of y, and second derivative, and so on up to the nth derivative of y. And if this is equal to 0, then this is an equation that involves y and its derivatives up to the nth derivative. So this is a defines ordinary differential equation of the nth order. Now, suppose we are given this equation first, without knowing these functions, but it is known that the function y satisfies this equation, this ordinary differential equation. Then any function y equal to y of x for x in some interval, then we say this function is a solution of this ordinary differential equation. For example, let's consider this second order, linear second order ordinary differential equation, and y is a function of x, say. And we can easily show that y of x sine x is a solution of this equation. To see this, just substitute this function into this equation. So y is sine x, and y prime is cosine x, and y double prime is negative sine x. So if we substitute this and this into here and here, then we see that sine x plus negative sine x is equal to 0. So indeed, this function satisfies this equation. Therefore, it is a solution of this ODE. But how can we find, without knowing the solution, just given this equation, how do we find this solution? That's the main question in the study of ordinary differential equations. So we will study them in turn. There are various methods, but it should be noted that not all differential equations are solvable. There are infinitely many differential equations that cannot be solved in analytical form. That means we do not have any solution, explicit solution like this. But in many cases, in most cases actually in the real world, we need to solve this numerically. That means by using computer simulations. But there are a class of differential equations that are solvable. So we are going to study some of these in later videos. See you later.